Oh, Ms. Voss. I haven't seen
it's
her.
fourth here.
Yeah, I haven't seen her since the end of third.
Okay.
Where'd she go?
10.
10? All right, so last time when we talked about this, all we started with was a quadrilateral. Today we're going to say our shape A, C, D, B. We're going to start knowing that it's a parallelogram. So one way or the other, we've already figured that out. So let me grab our first section here. Go. Let me get a better one. There we go. So we're starting with a parallelogram. We know we have a parallelogram. We want to decide, do we have a rectangle? So that's what we're going to talk about today. So these are theorems again, the things that we can use then to solve other problems, figure other things out about shapes. So the first one says if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So all we need, if we have a parallelogram, all we need is one angle to be a right angle. So we're saying the measure of angle A equals 90 degrees. So let's talk for a second about why that is true. So if this is a parallelogram, what do we know about opposite angles of a parallelogram? They're congruent. So angle A, if angle A is 90 degrees, angle B has to be 90 degrees. What do we know about consecutive angles, two angles in a row in a parallelogram? Supplementary. So these two angles have to add up to 180 degrees. One of them is 90 degrees, so the other one has to be 90. So if we know that one angle in a parallelogram is 90 degrees, we can figure out that all four are 90 degrees. And we have a parallelogram of four 90-degree angles, which makes it a rectangle. So nice way to figure out if we have a rectangle. The next one is called the house builder theorem. Our book doesn't really emphasize that much, but if you search things about rectangles, you'll find references to house builder theorem. I'll talk about why it's called house builder theorem in just a second. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So on my picture, I'm drawing the diagonals corner to corner. And what we're saying is that a segment AB is congruent to segment BC. And the reason that we call this the house builder theorem, or that it is called the house builder theorem, is that that people for a long time, they found evidence in ancient cultures and indigenous cultures now will use when they're building a foundation for a building or something. They'll start with the opposite sides being congruent. So they cut their foundation, whatever it is, a piece of wood or some stone or whatever, and they make sure that they're the same length. But they could arrange those same lengths. It could be a parallelogram because it could get kind of squashed over. To make sure that it's a rectangle, they would use a log or some rope and make sure that the distance from corner to corner, either direction, is the same, so that their foundation is a rectangle. So that's why they call it a house builder theorem. It's the way you can make sure the foundation of your house is a rectangle. And it's something people have been doing for a long time. So questions on those two? we have two different ways of deciding if we have a rectangle from a parallelogram. A 90-degree angle or congruent diagonals. All right, let's look at how we know if we have a rhombus. Let me grab these. And again, we're starting out knowing that we have a parallelogram. So we're saying that ACDB is a parallelogram. If one pair of adjacent sides of a parallelogram is congruent, then the parallelogram is a rhombus. So we need, on our picture, we'd be saying this. So we're saying a segment AB is congruent to segment AC. And we have one pair of adjacent sides. Adjacent means next to. So if we have two sides that are next to each other that are congruent on a parallelogram, that makes a parallelogram a rhombus. So let's talk about that one for a second. What do we know about opposite sides of a parallelogram? Opposite sides are congruent. So this side is, these two sides would be congruent, those two sides would be congruent. So if we mark them up, all four sides would end up with two of our tick marks. All four sides would be exactly the same length, and our parallelogram would be a rhombus. Parallelogram with four congruent sides is a rhombus. All right, let's look at the next one. The diagonals of a parallelogram bisect the angles. Then the parallelogram is a rhombus. We'll draw in our diagonals here, corner to corner. And we're bisecting the angles, so I'm going to do two different things here. I'm going to do tick marks for these, and for these others I'm going to use just the arcs. So this angle, that angle, and that angle are all being cut in half by the diagonals. So I'm going to say, instead of listing the angles that are congruent, I'm going to say angle A, angle B, angle C, angle D are bisecting. Remember, bisect means we're cutting them in half. So if we know the angles of a parallelogram are bisected by the diagonals, then the parallelogram is a rhombus. And then our last one. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So let's draw in our diagonals, corner to corner. And perpendicular means that they intersect how? 90-degree angle. So this angle is going to be a 90-degree angle. And I'll call that point E there in the middle. So we're saying the measure of angle AEC is 90 degrees. Let's talk about that one for a second. We only have to figure out one angle is 90 degrees because what do we know about these two angles, the angles above and below here? What kind of angles are they? Vertical. Vertical angles are congruent. How about these angles along here? They're a linear pair, and linear pairs are supplementary, so they have to add to 180 degrees. One of them is 90, so the other one has to be 90. So you can figure out all four of those angles are 90. If we know one angle on the diagonal is 90 degrees on a parallelogram, then we know that that parallelogram is a rhombus. So now we have some ways to decide if our parallelogram is a rhombus. We know how to show that a quadrilateral is a parallelogram, and we know how to show that a parallelogram is a rhombus or a rectangle. Any questions? Okay, just want to do a couple of examples, and then we will talk about last night's homework. So for these examples, I want to know, is the parallelogram a rhombus, rectangle, or square? So here's our picture for the first one. We know we have a parallelogram. We want to figure out what else we know about it. I'm going to draw the diagonals, and remember on these we need to go with what the diagonal tells us, or what the diagram tells us, not what the picture looks like. And I'm going to mark it like this. So we want to know, is this a rhombus, a rectangle, or a square? So for it to be a rhombus, we need to know either that the sides are all the same, we need to know maybe that the angles are bisected, or something about the angle on the diagonal. So the diagonals are bisected, but that's true of any parallelogram. So any parallelogram, the diagonals bisect each other. But what else do we know about the diagonals? If this is 7 and this is 7, how long is the whole diagonal? 14, and this 7 and that's 7, so how long is that whole diagonal? 14. So the diagonals are congruent, so that tells us that it is a rectangle. That's our house building. Because the diagonals are congruent, that tells us it's a rectangle. How about this one? So here's my parallelogram. We're starting with a parallelogram, and I'm going to mark it like so. So we're starting with a parallelogram. Is that a rhombus, rectangle, or square? Rhombus. And why is it a rhombus? The diagonals are perpendicular. And we're going to use a symbol. Remember, the upside down T symbol means perpendicular. It means they make a 90 degree. Because the diagonals are perpendicular, that makes this into a rhombus. Let's do one other quick example. So here's our picture. We want to know, this is kind of like our opener, what value of x makes this a rhombus? And we're going to say, just like before, we're starting with a parallelogram. So we know this is a parallelogram. We want to turn it into, we want it to be a rhombus now. So what value of x would make that, I would figure out what value of x makes that into a rhombus. Like,
Well, the way I solved it was 2 6 x minus 6 equals 90.
6x minus 6 equals 90, because we have to have a 90-degree angle, just like we talked about up here. So I'm going to add 6x plus 6 on both sides. 6x equals 96, divide by 6, and x equals 16. So if x equals 16, that makes that a 90-degree angle, and that makes our parallelogram a rhombus. Questions on that example? Okay, so we just added some tools to our toolbox to figure out some ways to figure out things about shapes. All right, let me write up the homework here on the board, and then we'll go over yesterday's homework. So homework today is page 372, 8 through 24 even, and then say the angle puzzle that I'll pass out and talk about in just a minute. And this is graded for accuracy. And in the formative category. All right.